Welcome to the online K-12 Basic Education Curriculum for Alternative Learning System, ALS K-12. Learning Strand 2, Scientific Literacy and Critical Thinking Skills. Module, Advances in Communication Technology. Lesson 1, Communication Technology Today. What is this module about? Technology is the general term for the processes by which human beings fashion tools and machines to increase their control and understanding of the material environment. In other words, we use technology to make our life easier. We innovate or create advances with the current technology to make things better. This is what technology is about. The impact of technology is magnified in the field of communication where major changes have occurred. In recent years, in this module, you will know more about advances in communication. You will learn the major communication tools used today as well as trends in the development of technology. In addition, you will learn about the problems faced in using these tools of communication. This module is divided into 2 lessons. These are Lesson 1, Communication Technology Today. Lesson 2, Present and Future Challenges to the Communication Technology. What will you learn from this module? After studying this module, you should be able to define what communication technology is, identify the characteristics of modern communication technological tools, explain the trends of development in communication technology, and explain some problems encountered in using modern communication technology. Let's see what you already know. Let's find out how much you know about the topics that will be discussed in this module. For each of the following statements, write T if the statement is true and F if the statement is false. If the statement is false, explain why. Number 1. Examples of forms of modern communication using technology are the television, writing a letter, and radio. 2. Communication technology makes it possible for you to send and receive messages anytime you want. 3. Television allows people to see places they haven't gone to. 4. Radio reaches a wider audience than television. 5. A document can be sent through email or fax. 6. The World Wide Web (WW) is larger than the Internet. 7. The World Wide Web is a network of linked documents. 8. A fax machine can receive documents but cannot send them. 9. Communication technology always causes greater business productivity. 10. The introduction of communication technology brought about new forms of crime. Let's check your answers. Number 1. Examples of forms of modern communication using technology are the television, writing a letter, and radio. Answer: F. Writing a letter is not a form of electronic communication. Communication technology requires the use of electronic devices. 2. Communication technology makes it possible for you to send and receive messages anytime you want. Answer T. Number 3. Television allows people to see places they haven't gone to. Answer T. 4. Radio reaches a wider audience than television. Answer T. Number 5. A document can be sent through email or fax. Answer T. Six. The World Wide Web is larger than the Internet. Answer F. The World Wide Web is only a feature of the Internet. 7. The World Wide Web is a network of linked documents. Answer T. 8. A fax machine can receive documents but cannot send them. Answer F. A fax machine can send and receive documents. 9. Communication technology always causes greater business productivity. Answer F. The use of communication technology can also cause less productivity for business companies. For example, the use of computers in making documents that are not related to work robs a company of its workers' time and productivity. 10. The introduction of communication technology brought about new forms of crime. Answer T. If all your answers are correct, very good. This shows that you already know much about the topics in this module. You may still study the module to review what you already know. Who knows, you might learn a few more new things as well. If you got a low score, don't feel bad. This means that this module is for you. It will help you understand some important concepts that you can apply in your daily life. If you study this module carefully, you will learn the answers to all the items in the test and a lot more. Are you ready? Lesson 1. Communication Technology Today. Major technological advances have occurred in the field of communication over the past years. Today, when we talk of human communication, we think of communication through technological innovations like the internet, cable television, and the telephone, etc. In this lesson, you will learn more about communication technology, its features, and its tools. After this lesson, you should be able to define what communication technology is, identify the characteristics of modern communication technological products, and identify the different tools of communication. What is communication technology? Some of you may know communication technology well. Others may only have a vague idea of it. Well, don't worry, you will find out the answer soon. What is communication technology? Let's watch a supplemental video on the future of human technology by Jason Silva.
So the philosopher Terence McKenna had a fabulous metaphor to express what he felt was the future of human communication. And he talked about an organism called the octopi. And he says that for the octopi, communication, language, was something to be beheld. The octopi wore its mind outside its skin. It can literally adjust its color to blend into its environment, to hide from predators, or to communicate with mates. The point being that its skin was a dynamic entity that could transform its colors in a kaleidoscopic frenzy to express intent, to express agency, to express mind. So that language became this thing, this three-dimensional thing in the world. And McKenna has said it from the beginning, that the world is made of language, that intentionality is everywhere, expressed in our DNA and in our behavior, not just when we move our little, vocal cords. And so you wonder about the future. You look at information technologies, you look at the rise of SMS, texting, Twitter, Facebook, FaceTime, Skype, techno-social wormholes, collapsing distance, human beings finding more and more ways to interface with one another, to express linguistic intent and agency until the whole planet becomes cloaked in mindedness. And this is the future. Virtual reality, technology, communication, the mind, the interior world turned inside out, expressed as a kind of coral reef animal that takes over the planet. This is the human agency. This is who we are.
Communication technology is the technology transmitting information through the use of electronic devices and systems. Examples of tools or systems of communication are the telephone, radio, broadcast television, and cable TV. Because most of these devices are systems enable us to communicate over large distances, communication technology has become associated with telecommunications. Telecommunications refer to the electronic collection and transfer of information from one location to another. The data being collected may consist of voice, sound, text, video, graphics, or all of these. The instruments that send these data include the telegraph, telephone, cable, radio, and television. The distance may be as small as within a room or as large as from here to outer space. Let's study and analyze. Study the picture on the right. What are the two women doing? How did they make use of communication technology? The two women were talking to each other over the phone. From the clothes they're wearing, you can see that they are far away from each other. Through the telephone, a product and tool of communication technology, the women are able to get in touch with each other despite the great distance between them. Characteristics. Let's learn the characteristics of products of modern communication technology. Communication technology has made great advances in recent years. Modern communication technology has characteristics that set it apart from past technology. Characteristic number 1. The key technology underlying all modern communication technology is electronics. In ancient times, before paper was invented, people wrote on clay tablets. For a long time too, documents were reproduced by copying them by hand. Much of this copying was done in monasteries. Books back then were literally restricted in libraries so that no one could take them. First major breakthrough in communications was the invention of the printing press by Johann Gutenberg in 1450. This allowed the production of many copies of books. Electronics and communications have gone a long way since then. The telegraph was introduced and later the telephone, the radio, and television. By the 1980s, electronics and communication had brought about huge changes in the way people exchange information with each other. Second characteristic. All new communication systems are interactive to a certain degree. That is, communication is two-way. They involve having the user enter his or her orders or responses to the communication device. For example, popular debate programs ask televiewers to call a given number to give their views on the topic of debate. They ask the viewers if they agree or disagree with a certain statement. At the end of the program, the answers are tabulated. The answers are announced according to our viewers. If you are not present in the studio where the actual debate is being held, your opinion is still counted. Third characteristic. Communication technological devices now have the ability to send and or receive messages at a time convenient for the users. For example, an answering machine allows you to record a message when the person you are calling is not around. That person can in turn get your message at his or her convenience. Let's try this. What tools of communication do you know of? How many were you able to write? Let's find out more about the tools of communication technology today. Let's learn. As I have mentioned previously, the tools of communication technology include the telephone, radio, television, fax machine, and the internet. Television. The television is an electronic system of transmitting images and sounds by means of electronic signals sent through wires and optical fibers. These signals are usually broadcast from a source, for example, a television station, to reception devices, such as television set in your home. At times, the source transmits the images and sounds to relay stations such as cable TV companies. The cable TV companies then transmit the images and sounds to your television set. Though most people will never meet the leader of a country, travel to the moon, or participate in a war, they can experience these things through the images on their television. Let's watch a supplemental video on how do television work by the Science Kid.
Hello! Welcome to the Science Kid. I'm your host, Quinn Friedman, and today's episode is the science behind the television. The television is one of the best inventions of human history. Watching something that could have been recorded anywhere in the world on your couch at home is just But how does this expensive modern technology work exactly? The first TV was founded by a man named Philip Farnsworth back in 1928. However, back in 1928, the television was black and white. Ever since then, the television has been completely remodeled to become the super fast flat-screen color TV we have today. There are three parts of the TV: the sender, the receiver, and the player. The senders are the transmitters. People working on specific transmitters will decode radio waves that will be sent by these big towers. Like we talked in the last episode, transmitters will send radio waves to all televisions. The second part of our television, the receiver, are our satellite dishes and satellite antennas. Most modern-day homes have one of these things built into the top of their house. These receivers take in the radio waves from the transmitters and transport them to the third part of the television. An object called a tuner blocks every channel except the channel the TV is playing. The last part, our actual TV, will take the radio waves and decode the message into visual light and sound waves. The visual light part of the radio waves are split into three. The three waves are red, blue, and green, the three primary colors. Each type of wave is transmitted into an electron gun inside the television. Like each wave, there are three electron guns. All three electron guns enlight beams of colored light into the screen of the TV. The three primary colors will mix to make every color on our planet. On the screen, there are rows of dots that play the certain color that the electron guns are sending. Each beam hits the exact dot because of magnets and a layer called a shadow mask that allows only certain beams to go through certain holes. In American TVs, the beams will emit 525 lines 30 times per second. Wow, that's a lot. After the image is played on the TV, a speaker will play sound waves that is decoded from the radio waves. I hope you enjoyed learning about televisions. Television shaped modern technology and is now used in airplanes, iPhones, and so much more. If you enjoyed, make sure to like, comment, and subscribe.
Radio. Radio uses sound effects to stimulate the listener's own images of people and places. The radio was invented in 1906 and for a time it remained primarily as a communication medium. It was devoted to sending and receiving messages, especially during the World Wars. As it developed, it was utilized for two types of service: entertainment and communication. After the war, radio broadcasting started. Radio reaches a wider audience than television. In provinces where there is no electricity, battery-operated radios are the main sources of news and entertainment. Nowadays, a radio comes as a component of sound system, which consists of speakers, a CD player, a cassette tape player, a recorder, and various switches and buttons that can manipulate sound. Let's watch a supplemental video on how does a radio work.
How does a radio work? Before getting into the details of how radios work, the electromagnetic spectrum, and more specifically, radio waves. Here's a standard sinusoidal wave. As shown, the amplitude is the distance from the baseline to a peak. The wavelength is the length from one peak to the next. The period is the time from one peak to the next. And frequency is simply 1 over the period. These characteristics are consistent in all waves, but have very different values as we move across the electromagnetic spectrum. As we see here, radio waves are on the very left end of the spectrum. This is because radio waves can have wavelengths up to 100 kilometers. In comparison, the wavelength of visible light ranges from 380 to 750 nanometers. So while radio waves surround us every day, we cannot hear or see them directly. So how does a radio actually work?
Here we have a transmitter. There are several elements that work together to generate radio waves that contain useful information, such as audio, video, or digital data. The first part of the transmitter is the power supply, which provides the necessary electrical power to operate the transmitter. Then, the oscillator creates alternating current at the frequency on which the transmitter will transmit. The modulator adds useful information to the carrier wave. The amplifier, as its name states, amplifies the modulated carrier wave to increase its power. And finally, the antenna converts the amplified signal into radio waves.
These radio waves are then captured by a receiver, which also has several elements working together. The antenna begins the process by capturing the radio waves. The waves are passed through to the radio frequency amplifier, which magnifies the weak signal. The tuner extracts the radio waves that are vibrating at the desired frequency. These waves are passed to the detector, which separates and sends the audio information to the audio amplifier. The audio amplifier boosts the weak signal to be played through the speaker.
We mentioned before that the modulator changes the form of the carrier wave. This change, or modulation, allows the message to travel over long distances and helps secure the signal from unwanted signal mixing. Modulation is generally done in two ways: amplitude modulation and frequency modulation, better known as AM and FM radio. In amplitude modulation, the strength or amplitude of the wave is changed in order to send the message. With FM radio, the carrier's signal frequency is the only thing that is changed, hence the name frequency modulation. FM radio works at a much higher frequency, consumes more power, and has much better signal quality than AM because FM receivers filter out noise interference better than AM receivers do.
One way to create a radio wave using simple tools is to rapidly connect and disconnect a 1.5 volt battery to a voltmeter. This will create a changing electric current as the potential in the circuit goes back and forth from 1.5 volts to 0 volts. As you do this, you will be creating a square wave. You will need a battery, alligator clips, and a cheap voltmeter to read the changing potential.
Telephone. The telephone is an instrument that sends and receives voice messages and data. Telephones convert speech and data to electrical energy, which is sent through great distances. A cellular telephone is designed to give the user maximum freedom of movement while using the phone. Let's watch a supplemental video on the history of telephone by I Didn't Know That program.
This is the technology that founded our entire telephone system. It's the cup and string telephone. This end has been rigged by our soundman Darren to mimic placing it to your ear with a microphone. I'm going back 30 meters to show you how well it works. Can you hear me? I can. Excellent. The plastic cup I'm holding acts as a diaphragm, so every time I make a sound, it vibrates. As long as the string is taut, those vibrations travel to the cup at the other end. That cup also acts like a diaphragm and converts those vibrations back into sound, so you can hear my voice. This is basically transmission of sound by telephone, and its discovery in the 1800s sparked up a race to produce the first device to transmit a human voice by wire. Workers began stringing out copper wires across the nation to carry telephone conversations, and new phrases started to enter the English language like "ring off" and "she's hung up on me." At first, telephones were considered to be so ugly that they didn't want them on display, so things like this crinoline lady were developed to cover them. Wasn't that better? Later, when telephone use became more widespread, people wanted to make their phones different, so they bought these lovely covers, like this velveteen thing. It really is nasty. But when people started to buy their own telephones, the designers really went crazy. Now listen to this. Each key not only plays a note, but dials a number. Great. Operator girls put through the calls, but at 8 p.m. they clocked off, as they weren't allowed to work the night shift. And if they got married, they had to give the job up. Over time, they were gradually replaced by electronic switches developed by an American undertaker called Strowger. As well as being sent along cables, phone conversations began to be transmitted on high-frequency radio signals called microwaves. In the 1980s, our phone system began to go digital, and our old cabling system was replaced by this, optical fibre. It's just a slither of glass that's as thin as a human hair, and it's so pure that if it was 20 kilometers thick, you could see straight through it. And cables made of optical fibers can carry millions of bits of information at once. Slowly, the whole network is being linked with optical fibers. They allow our voices to be carried along pulses of light, which makes them arrive quicker and clearer. Mobile phones first appeared in the 1980s. At first, only a few people owned them, mostly for business use. Now there are over 60 million mobile phones in use in the UK. In the 1990s, the growth of home computing meant phone lines were increasingly used to link PCs to the internet. Our love of surfing the net, or just chatting, means the phone is here to stay.
Fax machine. Fax stands for facsimile transmission or reproduction. The fax machine, therefore, is a system of apparatus for reproducing graphic material over a distance. A document is scanned by a fax machine and its reproduction is produced in the receiving fax machine. Let's watch a supplemental video on fax machine.
Fax. Fax is also known as facsimile. It is the transmission of a document or picture from one place to another place via telephone line. The facsimile or fax machine was first invented in 1842 by a Scottish electrical engineer named Alexander Bain. In a fax machine, there is a sensor which scans each line on the document, which is illuminated by a fluorescent lamp. Shown here is a scanned line. Each scanned line is divided into a number of equal short segments or elements called pixels. This group of parallel lines are transmitted through the phone line. At the receiving end, there is a mechanism to mark the paper with black dots. Each pixel is converted into an electrical current which is sent to the receiver. The receiving fax puts the picture elements together as it receives them until a copy of the original is made. Let's understand the functions of various parts of a fax machine with the help of a block diagram. The optical scanner scans the document to be faxed. Photoelectric transducer or sensor measures the amount of light reflected from each pixel and converts the light reflected from each pixel into a DC electrical signal. The signal is then modulated onto an AC carrier electronically. In case of digital transmission, data is encoded before modulation. The modulated signal is transmitted over a telephone channel. The fax receiver performs the reverse process of the transmitter. The received modulated signal is used to control the light intensity of a finely focused spot of light. The spot scans a photosensitive paper. The rate of scanning and phasing of each traversal of the page is kept in exact phase with the corresponding scan in the transmitter. Thus, an accurate photocopy of the original document is produced. Click on the optical scanner to know more. The scanning is done in two ways. In some systems, the document is laid flat and the spot travels across the document. This type of scanning is known as flatbed scanning. In other systems, which are most commonly used in fax machines, a document is wrapped around the surface of a drum, which is then revolved, causing the paper to pass the spot of light. This type of scanning is called cylindrical scanning.
Internet. The Internet is a worldwide system of computer networks. A computer network is two or more computers connected to each other. The Internet connects millions of computers to each other. The networks in the Internet can share information with each other. This is normally done through the World Wide Web, or WWW. In the WWW, multimedia files are created, displayed, and linked together. Multimedia files are text, photographs, graphics, video, and audio materials. These files can be accessed through the internet. Aside from the www, the internet has another feature, the electronic mail or email. Email is the transmission of written messages over the internet. Unlike letters sent through posts, email messages are instantly sent and received. An email message can also be sent to many people at the same time. Let's watch a supplemental video on what is the internet.
What is the internet?
The internet is like a popular thing.
Some satellites up there. I'm picturing my head with like waves of internet going to the phone. Somebody told me a cloud once.
The internet is a lot like plumbing. It's always moving.
Most people don't have any idea where the internet came from. And this doesn't matter. They don't need to. It's sort of like asking who invented the ballpoint pen or the flush toilet or, the zipper. These are all things we just use every day, and we don't even think about the fact that one day somebody invented them. So the internet is just like that. Many, many years ago, in the early 1970s, my partner Bob Kahn and I began working on the design of what we now call the internet. It was a result of another experiment called the ARPANET, which stood for Advanced Research Projects Agency Network. It was a Defense Department research project. Paul Barron was trying to figure out how to build a communication system that might actually survive a nuclear attack. So he had this idea of breaking messages up into blocks and sending them as fast as possible in every possible direction through the mesh network. So we built what eventually became a nationwide experimental packet network, and it worked. Is anybody in charge of the internet?
The government controls it.
Elves, obviously elves.
The people who control the Wi-Fi, because then no Wi-Fi, no internet. T-Mobile, Xfinity,
Bill Gates.
Bill Gates. Right?
The honest answer is, well, nobody, and maybe another answer is everybody. The real answer is that the internet is made up of an incredibly large number of independently operated networks. What's interesting about the system is that it's fully distributed. There's no central control that's deciding how packets are routed or where pieces of network are built or even who interconnects with whom. These are all business decisions that are made independently by the operators. They are all motivated to assure that there is end-to-end connectivity of every part of the network, because the utility of the net is that any device can communicate with any other device, just like you want to be able to make phone calls to any other telephone in the world. There's nothing like this that has ever been built before. The idea that what you know might be useful to somebody else, or vice versa, is a very powerful motivator for sharing information. By the way, that's how science gets done. People share information. So this is an opportunity for people to think up new applications, maybe program them as apps on a mobile phone, maybe become part of the continued growth of the infrastructure of the network to bring it to people who don't have access to it yet, or just make use of it on a day-to-day basis. You can't escape from contact with the internet, so why not get to know it and use it?
Let's remember, communication technology is the technology of transmitting information through the use of electronic devices and systems. Electronics brought about many developments in communication technology. Modern communication systems are interactive to a certain degree. They also enable users to send and receive information anytime they want to. Some of the major tools of communication today include the television, radio, telephone, fax machine, and the internet. Television is an electronic system of transmitting images through electronic signals. transmitted through wires and optical fibers. Radio transmits sounds. It reaches a wider audience than television. The telephone is an instrument for sending and receiving voice messages and data. The fax machine is a system of or apparatus for reproducing graphic materials over a distance. The Internet is a worldwide system of computer networks. The key feature of the Internet are the World Wide Web and email. Click the Take Exam button at the upper right corner to see what you have learned about advances in communication technology. Choose the letter of the correct answer. Participate in the discussion forum thread by answering the following question. If you were given the talent and chance to invent a communication tool, what would it be, and why would you invent such a device? Thank you very much for watching. Credits. Special thanks to all the people who made and released these awesome resources for free. Department of Education, deped.gov.ph for teaching guides and modules. Presentation template by Slides Carnival. Photographs by Unsplash. Videos. How do television work? How does a radio work? History of telephone. Fax machine. What is the Internet?